we have this function here, f of x equals x cubed minus 7x squared plus 15x. We should find the coordinates of all relative extrema of f of x. Find the coordinates of the point of inflection and sketch the curve of f of x. Okay, let's look at this. First of all, we should find the coordinates of all relative extrema. That means relative maximum, relative minimum points. Here, to find the coordinates of those, you're going to differentiate this function to find the gradient function. It's a cubic function, so it's probably going to be shaped like this or like this. Whatever the case is, if you draw a tangent to the curve at the peak of this hill or at this valley, they touch the curve at these points, the tangent will be horizontal, so the gradient is 0. Same thing for here. At the bottom of this valley or at the top of this hill, the gradient of the tangent will be 0. So you're going to differentiate to find the gradient function and then equate it to 0, then solve. So let's differentiate this. F prime x equals, this is going to be 3x squared minus 2 7s 14, 14x plus 15. Okay, good. Now let's equate this to 0 and solve it. 3x squared minus 14x plus 15 equals 0. This is a quadratic equation, so let's use a quadratic method. Let us use the quadratic formula to solve it. X equals negative b. We can see b is 14, negative 14, so negative b would be negative 14, which is positive 14. Plus or minus the square root of b squared. This is going to be negative 14 squared. Let's get our calculator. Negative 14 squared will be positive, so it's 14 squared, 196. So it's square root of b squared, which is 196, minus 4 times 3 times 15. So 15 threes, 45. 45 by 4 is going to be 180. So it's 180 that's going to come here. All over 2 by 3. Well, 2 by 3 is 6. So it's over 6. 196 minus 180. 181 is going to be 16 under the square root sign, you know. So what you will have is the square root of 16. But the square root of 16 is 4. So this would happen to be 4. So in this case, what you have is 14 plus 4, which is 18 over 6. And also 14 minus 4 is 10. 10 over 6. Let's put these in decimal form. 18 over 6, that's 3. So it's going to be 3. And 10 over 6, which is the same as 2 into 10, 5, 2 into 6, 3. 5 thirds. 5 thirds is what? This is going to be 1 and 2 thirds, which is 1.667 then. So let's call it 1.67. The 3 significant figures, that's 1.67. So you have 2 points where x, these 2 locations of x, where the stationary points are, or the relative extrema are located. But you're asked to find the coordinates. Since you're asked to find the coordinates, you're going to find the value of y. where these are located to. So let's go up a little further and calculate the y values. All right, so here for x equal 3, well, I said y values, but in this case it says f of x, so let's call it the f of x values. We're going to be 3 cubed minus 7 by 3 squared. So 3 cubed minus 7 by 3 squared. What else does it say? Plus 15 by 3. Plus 15 by 3. Alright, so what does this give you? Let's draw for our calculator again. So what you have is 3 cubed, 3 3 is 9, 9 3 is 27, that's 27. Minus 3 3 is 9, 9 7 63, minus 63. Plus 15 by 3, 45, 45 equals, and you have 9. So f of x is 9 when x equals 3. Let me just write this as f of 3 then. So f of 3 is 3 cubed minus 7 by 3 squared plus 15 by 3. So now we're ready for f of 1.667. We wrote 1.67. Alright, let's use 1.67 equals, so it's going to be 1.67 cube minus 7 times 1.67 squared plus 15 by 1.67 equals, alright, what does our calculator say now? 1.67 cube, alright, the same as 1.67 by 1.67 by 1.67, alright, equal 4.65, that minus 7 times 1.67 squared, it has a square here, equals, okay, plus 15 times 1.67 equals 10.185. Call it 10.19. So we have 10.19. Alright. So we have the coordinates of the stationary points. Let's write them down. It's 3 when x is 3, y is 9. So one of them is located at 3, 9. Where's the other one? Oh, you're going to have the other one at 1.67. What was the figure again? 10.19. 1.67. I'm going to have to remove part of this. It's 1.67, 10.19. So those are the locations of the stationary point, of the extrema. One of them will be a minimum point, the other one will be a maximum point. Alright? Now, to find out which one is minimum, which one is maximum, we're going to differentiate again. So we will find the second derivative. When we find the second derivative will tell us how the gradient is changing. Alright? We're going to find the second derivative and put 3 in it. If we get a positive value, then it means that part of the curve will be a minimum point, because a positive value would mean the gradient of a tangent is changing, is increasing as you go from left to right. If it's minimum, then it's a maximum. If it is negative, it's a maximum point, because the gradient of the tangent is high, here is getting lower and lower, so it will be falling. Alright, so Let's do that. Let us find the second derivative. We have these things here. We have the first. All right, let's find the second derivative right here. F double prime x equals. This is the first derivative. We differentiate this again to find the second derivative. It is going to be 2 times 3, 6. It will be 6x minus, when we differentiate 14x, we get 14. All right, so we have 14 here. 6x minus 14. All right. I guess we can erase some of this now to get some space, make some space here. So now, what we have here, if we put 3 into it, f double prime of 3, we get 6 by 3 minus 14. That's going to be 18 minus 14, which is a positive. This is a positive value, positive 4. All right? You just write 4. You know, once you see 4, you know it's positive. So, what you have at this point with the x equal 3 is a positive, so there will be a minimum point here. All right? So it's a minimum point, and this you expect to be maximum, but we can just do the calculation. F double prime of 1.67, x is 1.67 at this point, is going to be 6 times 1.67 minus 14. What is 6 times 1.67? So we have 6 times 1.67 equal, that's 10.02, minus 14 will give you a negative 3.89. Negative 3.89. From the fact that this is negative, it means you have a maximum point here. All right? Now, the coordinates of the point of inflection, we can see so far that this point, first of all, let's open another screen. We have 3, 9 and 1.67, 10.19. Let us have our x and y axis here. We have 3, 9, and what else? 1.67, 10.19, 1.67, 10.19. The 3, 9 is minimum, so this is a minimum point, and this is a maximum point. So if you have a graph like this and you consider 1.67 to be here, so all right, you have 1, 2, let's space them out a bit more. Have 1, 2, 3, then you have 3, 9, so you go up to 9. This passes 10, so let's say this is 5. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So the first point at 3, 9 will be about here. And the second point, 1.67, 10.19, will be a little higher, about here. This is a minimum point, right? So this is a minimum point. What would this be? Minimum, maximum point is here. 39. This is 1.67, 10.19. I'm mixing it up. At 1.67, here 10.19, you have a maximum point. So the shape of the curve is like this here. At 39, you have a minimum point. So 39, a bit far. So curve is going to be shaped somewhat like this. Right? Now, we're going to draw the rest of the curve a little later, but find the coordinates of the point of inflection. Now, the point of inflection is going to be somewhere within this region between the two extrema. All right? Where the tangent was swinging downwards, then it started to swing upwards, and that change is going to be somewhere in this region, but let's calculate it. How we get that is from equating the second derivative to 0. The second derivative is telling you how the gradient of the tangent is changing. And at the point of inflection, it stopped changing momentarily, so the change is 0. So 6x minus 14 equals 0. 6x equals 14, so x is going to be 14 over 6, which is 7 over 3. 7 over 3 is what? 3 into 7. 3 into 6, 2. 2 and 1/3. 2.3. Alright, call it 2.3. So the point of inflection would be at around 2.3. And the next thing now is this. Sketch the curve. Alright, we're going to have to sketch the curve. So we need to know where the curve cuts the x or the y axis. It will cut the x and y axis somewhere. If we make x equals 0, f of x is going to be what? I said y, but it's the same as the f of x axis. Alright, we have to look back at the original function. If x equals 0, f of 0 will be, when x is 0, that's the y axis. Where will it pass and cut the y axis when x is 0? Or the f of x axis, right? So remember, if you have the f of x axis and the x axis, when x is 0, it's along the f of x axis. So where will the curve meet the f of x axis? Let's see. This is 0 cubed, which is 0, minus 7 by 0 square, which is 0, plus 15 by 0 is 0. Oh, so it's 0. So when f of x is 0, when x is 0, f of x is also 0. So that suggests that the curve would pass through the origin 0, 0. Alright, so suggests that this is what the curve would look like. So sketch the curve of f of x. This is what the curve would look like. So this extreme point is, call it point 1. It's at 1.67, 10.19. Alright, and the next point is at here, is at 3.9. So this point is located at 3.9, and this point here is located at 1.67, 10.19. Let's put this to a test. Suppose we should use GeoGebra or graph plotting software to plot the graph. Would it look like this? Well, Let's test it out. Okay. What was the original function again? X cubed minus 7x squared. Let's maximize GeoGebra. So we have x to the power of 3 minus 7x to the power of 2. What else does it say? Plus 15x. Plus 15x. Okay. Let's make, this is part of our graph. Let's set it up a bit first. Let's make it thick. And I like to see the equation on the graph. Let's zoom out and see it wider. Oh, okay. We have things happening up here. Let's zoom in. All right, let's see what's going on here. This point here is at 1.6710.19. So let's see now. 1.67. Now this part, this part of the graph here. Let's project down. It seemed to be at 1.67. It's a little past 1.5. Okay. 10.19 is a little higher than 10. You can see that, right? If we zoom in some more, we can see that it passed 10. It's 10.19 and it's a little less than 10.2. Good. So we have that. All right. Now, what about the other point? Let's zoom out enough so we can see the values on the x-axis for comparison. We said the other point was at 3, 9. Oh, and it passed through the origin. We can see here the curve is passing through the origin. Good. 3, 9. This is our tree line here. Oh, so you see it meets at 3 and at 9. Let's zoom in and you can see it's at 3, 9. Good. So we do have the curve here exactly as we want it, as it should be. All right. So that will be it for this video. I'll see you later.